Hi, hello friends. Welcome back to TRB revision series. So here we are revising the complete syllabus of all electrical and electronic subjects. Of course, we'll be focusing on only very few part of electronic subjects, but for electrical we'll be covering the whole syllabus. As the part of this, we have already completed signals and system. So this session has been intentionally dedicated for only two exams, as I told already. One is for TRB and another one is for Barc exam. So let's continue. So presently we are doing analog electronics. We are revising analog electronics. Already we have completed signals and system. In analog electronics, in the last class itself, I have been told you in which order we are going to continue this class. What will be the pattern? How we are going to revise all the chapters one by one. Everything I have already discovered. Now, what we are going to do is we are just giving the continuation from where we left in the last session. In the last class, we were discussed about bipolar junction transistor. I have given the complete description, that is detailed explanation for BJT and its symbolic representation and what we are doing in DC analysis. After that, we have also started AC analysis. We have revised how to draw the AC equivalent circuit of a bipolar junction transistor, and we saw this can be represented in three different categories. So we can draw the circuit in RE model. There are three different analyses are available in AC circuits. One is RE model, and the second one is R pi model, and the last one is hybrid model. We have seen the equivalent circuit of all these three models, how to draw the AC equivalent circuit. Then at last, I told you that in this session, I will be showing you some of the standard circuits which will be often or directly asked in your examination. And I will also give the direct formula, don't worry. You can keep it with you. If you are remembering those formulas now, when the question will be directly asked from those standard circuits, it is very easy for you to give the answer by remembering the formulas in one step without doing any calculations. Let's see, we know in bipolar junction transistor, we will have different types of common configurations. If you observe, we will be having three terminals. Based on the three terminals, we can design common emitter configuration. We can also design common collector configuration. Then we can also design common base configuration circuits. So most of the questions will be directly framed on AC analysis. Most of the questions will be directly framed from these three configurations only. Now, however, it doesn't matter how they are framing the questions. In AC analysis, they will ask, especially they will focus on mid-frequency analysis. Most important area they will focus is mid-frequency analysis. In mid-frequency analysis, the most importantly asked four repeated questions are, they will ask you, you will be requested to calculate the input impedance. You will also be requested to calculate the output impedance. You will also be requested to calculate the voltage gain. You will also be requested to calculate the current gain. That is what the overall questions that they will ask from AC analysis. So it is very important to know how to calculate all these parameters when a simple circuit will be given to you. Now, for an example, let us assume a common emitter configuration is given to us. Let us consider a common emitter configuration. How it is seems like, sir. I will show you the structure of the common emitter configuration. We will have certain resistor, then we have to consider transistor. Then on the input side, I have to consider some resistor. Let me connect all of these people. Then here I am giving the supply. Then it is connected with the ground. And here I am going to connect some resistor for time being. I will explain how it will be ignored. Okay. Done. So we will connect some collector resistor here. And from here we are going to measure the output. This is the point where we are going to measure the value of output voltage. Fine, sir. Let's redraw. Sorry. Let me connect few more parameters. Now the thing is, on the collector terminal, let us assume there is a resistor and we are calling it as collector resistor RC. DC supply voltage for the collector terminal is VCC. So here the capacitor that is usually connected across the collector terminal. So we are calling the CC here. And on the input side, let us consider some resistor. And I will be considering this is our input voltage. Emitter resistor also given. And a bypass capacitor has been connected here. Assume we are connecting a bypass capacitor here. So CE across the emitter we are connecting that bypass capacitor. So next everything is done, sir. What is our next target is, so this is our output terminal V0. This is going to be NPN transistor emitter terminal and this is going to be our base resistance RP. Suppose if a circuit will be given like this in AC, while doing mid-frequency analysis, so how to calculate all the parameters? That is the question. How to calculate all the parameters? The parameters are input impedance, output impedance, voltage gain, current gain. How should I explore all these things? I will tell you this is very simple. First step, in order to explore all these parameters, you will have to perform AC analysis. Only in AC analysis we are calculating all these parameters. And when we are preparing for, as we are preparing for Barc and TRB, questions will be asked very small questions. Even they will not ask a detailed explanations. Very small questions they will directly ask in the exam. So it is not important how detailedly we are going to derive. All you have to know is how to perform. A very simple circuit will be given. Even this much of bigger circuit not will appear in your examination. I will just to show you how to do. That's it. Understand the procedure. You will be facing a very small questions. Easily you can give the answer for the questions that they are giving in the exam. Okay, sir. Hope you understand. So let us continue from here. What we are going to do now is, the thing is, the first step, we have to perform AC analysis in mid-frequency analysis. All these bypass capacitance, the capacitor that is connected on the base terminal, if they are connecting capacitor on the output collector terminal, all these capacitors CC, CB, CE, all are going to be short circuited. First thing, all these capacitors are going to be short circuited. So what you have to do, sir? You will have to short circuit. That is the first keyword that you have to remember while performing AC analysis. And the second step, we will have to deactivate all DC sources. Deactivate all DC sources. Sir, how to deactivate the DC sources? Suppose if there is a current source. It is very rare to give current source, but they will give. Still they will give. If they are giving current source, just to open circuit. They will give current source most of the time across the base to emitter terminal here at this point. But it doesn't matter, just to open circuit the current source. That is how we are deactivating the DC current source. If it is a voltage source, then simply short circuit and connect it with the ground. Now if you observe in our circuit, let us start. This is the second step. After that, draw the AC equivalent circuit. Draw AC equivalent circuit. Draw the AC equivalent circuit. Once you've done that, then everything will be fine. Done, sir. So let's continue. Let me start. For the given circuit, how to draw the AC equivalent circuit, sir? First step, we will have to short circuit the capacitor. We will have to short circuit the capacitor, and I am going to perform. We saw 3 model. I am doing this under RE model. Sir, it doesn't matter. All the models will be similar. Don't worry. They will ask the question in RY model or RE model or hybrid model. You know the relation. In the last class, I had given the relation between all the 3 models. So you will perform any one model which is convenient for you. Okay, let's continue. RE model. They will ask in the exam whether they are, by observing the option, you can easily predict whether they are asking this answer in RE model or RY model or hybrid model. Based on the options, you can choose the best method that will suit for that particular question. So let us continue with that. RE model. First step, replace the transistor by its equivalent circuit in RE model. We know from the base terminal, we will have to connect one resistor. Then across the collector terminal, we will have to connect one current source. Then this is going to be emitter terminal. And if you observe, this is beta times of IB. and this is going to be a collector resistance. See, this current is going to be base current, and I said that is beta times of RE in RE model, and this is going to be your emitter terminal. After doing these things, what is your next task? So this is going to be your emitter terminal. Now let us connect all the parameters that will be given in the question for us. If you observe the given question, sorry, we have to catch the given diagram. So in the given diagram, all we have to do is short circuit the capacitors. So this will be short circuited. This capacitor is short circuited. Now observe, see, once your capacitor is short circuited, then this resistor will dice out because current will always choose low resistance path. When there is a short circuit, you will not be able to consider this emitter resistor, skip it. So across the emitter terminal, directly it will be connected to the ground. Now whereas collector terminal on the top, see that I am going to connect it to the ground. So here the capacitor is short circuited. Everything is done now, sir. Now on the input side we have the AC voltage. This is very important. You will have to keep. On the base terminal you will have to connect it with the RB and the source. Collector terminal is going to be connected with the resistor RC with the ground, and the emitter terminal is going to be connected with the ground. That's it, sir. Now let me continue with that. So what we found, this is collector terminal. Across the collector terminal there is a resistor and that is going to be connected with the ground RC. And here we are measuring the output voltage V0. On the input side, base terminal, it is connected with one more resistor, that is base resistor RB. Then it is also connected with the input supply voltage Vn. That's it, sir. This is the complete circuit, and the emitter has been connected to the ground. Once you've done this, next let us see how to calculate the input voltage gain and the current gain is everything one by one. I will tell you. It is very easy. First, to focus on the output side. While measuring the output side, whatever the resistor that they are giving now, one thing you should remember: whatever the resistor that is lies across the collector terminal, that resistor will be the collector terminal. Between collector terminal to ground, we have RC. Across this, whatever the voltage that you are measuring, that is nothing but V0. Now, if you observe, there is a current that is beta times of IV. That current will be coming out of this RC only, collector resistor. Because based on the direction, you can guess. The current will be going like this, no, sir. Then from where it is coming? From here only it should come. There is no any other path. It is just a terminal. We are measuring the voltage. We are not injecting any current. Now, from the direction of the current, for a resistor, resistor is a passive element. From the basics of circuit theory, we know resistor is a passive element. So current entering point is plus, leaving point is minus for your resistor. Now from the direction of the current will be traveling in the upward direction, sir. Whereas we are measuring the voltage in the opposite polarity. So first, in terms of current, this resistor is RC and the current that is entering into this branch is beta times of IV. Then in terms of current, how will you write down the voltage drop, sir? From the Ohm's law derivation, from the mathematical derivation of Ohm's law, I can say the voltage drop across this resistor can also be written as current flowing through the resistor into the value of the resistor. After that, now if you observe, this is nothing but voltage drop, and this voltage can also be written as V0. But the problem is V0 polarity, and in terms of current also we measured some voltage drop, both are in opposite direction. So you will have to consider V0 equal to minus beta times of IV into RC. So what we found successfully, we found the relation, the output voltage can be written as minus beta times of IV into collector resistance RC. Treat this one as your equation number 1. Now the next one is, you will have to focus on the input side. When we are focusing on the input side, see there, just apply KVL for this loop. It is connected to the ground. Here also it is connected to the ground. If you are applying KCL, see, this is the standard representation. Current entering point plus leaving point is minus, entering point is plus, leaving point is minus. If you are applying KVL, we can write minus Vn. I will write somewhere there because this is final answer writing point. So what I will say is, can I write like this? Minus Vn from the input voltage plus the voltage drop across the resistor RB. This can be written as current, base current IB into resistor value is RB plus the voltage drop across the resistor beta times of RB. Beta times of RE into current flowing through it. That is how we are applying Kirchhoff voltage law. From this expression, what you can say is the input voltage Vn is going to be, it can be written as base current IB inside the bracket base resistance RB into beta times of RE. Correct now, sir? Treat this one as your equation number 2. That's it. This is over. Now, if you observe from the input side, the current that is coming from the input terminal is base current IB. And on the output side, collector terminal is the output side and the current is called collector current. We know collector current only can be written as beta times of IB. Yesterday we saw the relation between collector current and base current is IC equal to beta times of IB. This is what I am doing here. Now, you know the output current. This is output current. Yes. So what I can say, the third one is input current is simply equal to base current because that is where we are having our input terminal. Output current is nothing but collector current IC. Output current is nothing but collector current IC, and of course the output current is going to be, usually one thing what you have to understand is output current means we will be always receiving the current. The output current is the one which is coming out of the circuit. That is the only thing. But whereas here across the output terminal current is going inside, sir. This is standard representation from the standard circuit. Current is going inside, but usually we will be measuring the output current in the opposite direction. It should come out of the circuit. Here it is going inside. Because of that reason, we will be putting minus here. Just remember that. So this is going to be minus beta times of IB. This is your output current. Now we know input voltage, output voltage, input current, everything. What we are going to do with this, sir? Just to take the ratio. Nothing. I'm not going to do anything with this. I am just going to teach you how to calculate the value of gain. So I will tell you now. So the final answer. See then, it is very simple, sir. How easy it is, I will show you now. A very small circuits will be given like this. All you have to do is, if you practice some 2 to 3 problems now, it seems like if you are very new to this practice zone, it seems like a difficult one. If you solve 5 to 6 questions, AC analysis is the easiest part in entire analog electronics. Very easy. Other part also easy, but it is very easy. So I can say now the question is voltage gain. It is the ratio between output voltage and input voltage. How will you measure, sir? Output voltage is minus beta times of collector resistance RC into base current IB. Whereas input voltage what is base resistance plus beta times of RE into the base current IB. So base current will get cancelled at last. The voltage gain for the given circuit is minus beta times of RC upon RB plus beta times of RE. That's it, sir. This is your final answer. This is how we are calculating the voltage gain. Now, suppose if they are asking current gain, then you will have to take the ratio between output current divided by input current. Just now we saw output current is minus beta times of IB divided by input current is going to be simply IB. So both will get cancelled. This will be equal to minus beta. This is current gain. So beta can also be written as C minus HF. Do you remember beta and forward current gain HF? This is hybrid model. In hybrid model, this beta is equal to HF. We are in RE model. In RE model, we are getting beta. If you are doing hybrid model, this will be equal to HF. That's what I am saying. It doesn't matter which analysis you are performing here, whether you are performing RE analysis or RPi analysis or hybrid analysis. We know the relation between all these 3 models. In the last class also I have been described this. With the help of this, you can easily figure out the final answer. That's it, sir. Now we know the voltage gain. Of course, we also know the current gain. What is our next task? The next task is you will have to find out the value of output resistance. In order to know the output resistance value, output resistance is nothing but the ratio between the output voltage and the output current. We know the value of output voltage, that is minus beta times of RC into base current IB, and we also know the output current, that is beta times of IB minus beta times of IB. Minus beta, all these things will get cancelled. So finally you can observe that collector resistance is nothing but your output resistance. See that how simply we found the value of output resistance. One step. If you are preparing for TRB exam or Barc exams and all, they will ask these type of direct questions only. You will be thinking that, sir, a very big question will become, how they can ask this much of big question in a small exam? Yeah, of course, it's a state exam, and within the given time, they can frame only small questions. But They will give tricky, sir. They are intelligents. They are having sufficient experience to make tricky questions. It can seems to be a smaller one, but it will be having a trickies. So you must practice how to calculate all these parameters. But I'm saying no, in AC analysis, they will frame only direct questions. There will be not, there is no possibilities to keep trickies here. All you have to do is remembering the proper procedure, how to analyze. And one more thing, do you know, the surprising thing is this is the one and only method that you have to apply for all type of configuration. Measuring the output the same way that I did here, you will have to measure the output voltage, input voltage, output current and input current. It doesn't matter what type of configuration that they are giving to you. Okay, sir. So we have measured the output resistance now. So our next target is measuring the value of gain. Let us keep our attention with the gain. Okay. So the next one, what we are going to do now is we are going to measure the value of gain. That's it. So let me proceed, sir. Sorry, not gain, input resistance. Forgive me. So the next focus is with our input resistance. When we are observing input resistance, that is nothing but the ratio between input voltage and input current. Input voltage and input current. As we know, we already done this input voltage, that is beta times of RE plus base resistance RB, no, sir, I'm correct, into base current IB. This is input voltage and input current is nothing but base current, so this will get cancelled. So the value of input resistance, we can simply define that is equal to what? This value is going to be beta times of RE plus base resistance RB. That's it, sir. That's it. Now suppose sometimes in the examination what will not happen is the base resistance will disappear. They will not give the value of base resistance. If the base resistance is not given, then what you can do? You can write only beta times of RE. But remember, this beta times of RE is nothing but R pi. Do you remember? Pi model. In pi model, R pi is equal to, in RE model, that is equivalent value is beta times of RE. From this also yesterday, I derived that this is equal to beta times of RE. But RE equal to 1 upon GM. From this beta can be written as GM into R pi. Remember the relations, sir, all are very, very important. Don't forget any of the things here. Now, there are two type of questions will be framed. One more thing I would like to conclude. What type of question is? Sometimes they will frame the question with the overall input gain. The voltage gain that we have calculated is overall value. Suppose if they are asking it from this terminal, this arrow mark will be given. If they are highlighting this arrow mark now, then you will have to measure. Just assume there is a voltage that is your base voltage. For the given transistor, instead of focusing on external parameters, only for the given transistor, if they are asking the voltage gain, in that case, you will have to assume there is a voltage here that is connected with the ground. They will mention this point. From here, you will have to measure all the parameters. Don't consider this input voltage. I was doing all this analysis by considering the overall voltage gain, by treating the overall circuit from the input point. If they are if they are highlighting the arrow mark and they are requesting you to calculate the voltage gain or all other parameter, then repeat the same thing. Just again apply KVL here. In that case, what will happen, sir? The input voltage is nothing but base voltage. This will be simply equal to beta times of RE into base current IB only will come. Base resistance will not be included. If they are marking the zone, if they are highlighting from here, calculate the value of voltage gain. That is internal voltage gain. If they are asking overall voltage gain, then you should calculate it from here. Understand, sir? These type of questions also will also be usually framed when we are approaching for TRB exam or the local exams, any type of exams. If beta is given very large, then beta equal to 0. No. See, if beta is very large, it means the base current is approximately equal to 0. Anyway, this analysis we will have to perform in only DC circuits, in DC analysis. Don't do this kind of things in AC analysis, okay? AC analysis is different, DC analysis is different. So here, you should not bring this type of relations in AC analysis. Remember that. Fine, sir. So let me continue. So now I have been told you how to calculate all these parameters. So in the same way, in the examinations, whenever any general circuits will be given, all you have to do is just remembering the procedures, how to perform this. Okay. Now I will tell you Some of these standard circuits I will bring and I will write the answers. Just to try to remember, as I told you, this one circuit. In the second, they will take the same circuit, but what they will do is, see, observe, they will give collector resistor, they will give base resistor, they will give everything. In the last question, we have been bypassed with the emitter resistor. Suppose if the emitter resistor is not connected with any capacitor, it is simply given only base resistor is given, and they have connected one input supply voltage here. So a simple circuit will be given. As usual, they are measuring. They have given one certain capacitor and they are measuring the output voltage here. Collector resistor RC will be given and the VCC will be given here. So how should I perform this? Same thing. What you have to do? All you have to do is just to draw the AC equivalent circuit, but this time what you must observe here is the capacitor will not be deactivating the emitter resistor. Last time across this capacitor we had across this resistor we had a capacitor. Because of the short circuit effect of the capacitor, I was ignoring the effect of emitter resistor. But this time we are not going to ignore the effect of capacitor. Okay, right. So let me continue. Now from this, what I would like to say, the conclusion is, let me continue. So capacitor is not there, effect is not there. So if you are drawing its AC equivalent circuit, how will you draw, sir? So start from the base terminal. AC supply voltage will be given. After that, a base resistance will be given. Now we know how to replace the transistor. The transistor equivalent circuit is going to be, we will have to consider a resistor beta times of RE. After that, there is the emitter that will be connected with the, so directly I am going to connect it with the, see here we have one resistor, one emitter resistor RE. Let me consider it here. After that, on the input side, collector terminal side, sorry, not input side, this is going to be beta times of IB. We are performing RE model only, sir. On the output side, the collector resistor will be directly connected to the ground because we are performing AC analysis. While performing AC analysis, all DC supply should get short circuited. DC voltage sources will get short circuited. Meanwhile, all capacitors also will going to be short circuited. This coupling capacitor CC and this CB. If CE is given, that is also bypass capacitor. CE is usually, if your resistor is connected in parallel or across RE, usually that will be short circuited. That is the basic property. Sir, that is a basic thing that we have to apply in mid frequency analysis. Fine, sir. Since that is not given, so this is the equivalent circuit. All you have to do is approach the same way. Whatever I did, you can perform the same analysis again. Calculate the voltage gain, current gain, all the things. See, assume there is a base current here. That is not assumption, that is what's happening here. And we are measuring the output voltage here, and the current will be entering here as usual. From the direction of the current, this is the polarity, and you can find out the voltage drop in terms of current. So if you are finding that, you can say that the output voltage V0 is going to be minus beta times of IB into RC. This is how we are measuring the output voltage, sir. Now, when we are focusing on other parameters, now suppose the next one here. Now this time the emitter resistance is not ignored, sir. Base current IB is coming here, and from here beta times of IB is coming. If you are adding this, we know emitter current can be written as 1 plus beta times of base current IB. Yes, current entering point plus leaving point is minus. You can explore the voltage drop now. We know the output voltage expression already. Now I will teach you how to draw the on input side. As I told you, there are two ways of observing the input voltage gain. One is overall voltage gain from the input source. The another one is from the base terminal. Exactly from the transistor terminal, they will measure the voltage gain. So there are two ways of approach. You will have to focus on which terminal they are doing all these things. Okay. So let me continue and I will teach you how to calculate all these things one by one. Yes. Sir, first, as usual, as I told you, apply KVL. Whenever you are calculating voltage gain, current gain, whatever it is, first apply KVL. Write down the expression for input voltage. So we can consider top is plus, bottom is minus always. So minus Vn plus, since the base current IB is the input current that is going through the base resistor and the emitter resistor beta times of RE, not emitter resistor, base resistor. So equivalent value is beta times of RE, and here we will have to complete the whole circuit now, sir. 1 plus beta times of IB into 1 plus beta times of IB into RE. That is the voltage drop across this resistor. Now if you are applying KVL, this will give you base resistance RB into base current IB plus the next one beta times of RE into base current IB plus 1 plus beta times of base current IB into emitter resistance RE equal to 0. Successfully we wrote the expression for pole. Now from this I can write the input voltage Vn can be written as take base current IB as common outside. So this can be rewritten as base resistance RB plus beta times of RE plus 1 plus beta times of emitter resistance RE. Treat this one as your equation number 2. Now we know the value of input voltage expression. We also know the value of output voltage expression. Now the next task is write down the expression for input current and output current. That is similar. How will you write down? I can say input current equal to base current. There will be no doubts. But the output current direction, usually output current is the one which we are receiving from the circuit. See there, output current is the one which is coming out of the circuit. That is called output current. We are trying to receive the output current from the circuit. So from that, what I will have to say is output current is the one which will be coming out of the circuit, whereas here the actual current is going inside the circuit. So what I will have to say is the output current is in the opposite direction to the current that is originally flowing into the network. So from this I will have to say the output current is equal to minus collector current IC, or I can say minus beta times of base current IB. There is no changes in this, sir. Okay, now let's continue from here. What we are going to do, calculate all the things. The first step, voltage gain. I am doing overall voltage gain. So the overall voltage gain means overall output voltage divided by overall input voltage. What is the overall output voltage? Minus beta times of base current IB into collector resistance RC divided by input. What we saw, sir? On the input side, I hope we saw base resistance. Then we crossed the beta times of RE. Then we crossed the 1 plus beta times of base resistance RB. Then along with all this, I made one mistake here. That is, this is RE, not RB. With this, we will have our base current. Of course, these two people will get cancelled, and this will become minus beta times of RC upon the overall value is going to be base resistance plus beta times of RE plus 1 plus beta times of emitter resistance RE. Perfect, sir. So in the examination, observe the options. Sometimes what they will do now, in place of beta times of RE, they will use R pi, or they will use HI in terms of hybrid parameter. All these people are equal. We know, yesterday class I have been derived all these things. Similarly, now explore it for current gain. The current gain is nothing but the ratio between output current and input current. How will you derive the output current, sir? Output current is the one that is minus beta times of IB. Just now we saw, because output current and collector current are opposite to each other. Collector current can be written as minus beta times of IB. Input current is going to be simply base current IB. So base current will get cancelled. This will be equal to minus beta. In simple word, we can say the value of current gain is going to be minus beta, or we can say we know the value of minus beta is equal to forward current gain in hybrid model. And this will also equal to, see there, we know beta times of RE is equal to R pi. And we also know from this what I can say, beta can also be written as R pi into GM. Correct, na, sir? So when we very well aware of these things, in the examination what they will do is, instead of giving beta, they will give R pi into GM. Don't get confused, both are equal. Both these things will give same answer only. So either they will write down this way, or they will write down in this way, or they will give the option in this way. All you have to do is remembering all way of approach. So now you know how to calculate the voltage gain, current gain. What is our next task? Focusing on input and output impedance. So let's do that. The input impedance is the one which is giving the relation between directly input voltage and the input current. If you are observing the input voltage, just now we saw the relation, that is I have to start from base resistor, then we have to cross beta times of RE, then we have to cross 1 plus beta times of base current IB. That is the overall voltage gain. Of course, I left one more term, that is emitter resistor RE. And in the denominator, simply in simple words, see, base current is the common one for all these people. Okay. So what you can do is, oh sorry, let it be. So what I will do now, I will keep the overall value is common, the base current. Now these two people will get cancelled. So the input resistance will become simply RB plus beta times of RE plus 1 plus beta times of RE. Okay, this is your overall input impedance when it is given in the exam. So you will have to approach in this way only. Sir, remember, I told you there are two types of voltage gain. If we are ignoring the value of base resistor, it means, as I told you, while measuring the voltage gain, if they are focusing on the voltage gain from the base terminal directly, internal voltage gain. See, if they are not focusing on overall voltage gain, rather they are ignoring the output part of the circuit, external circuit. They are only focusing on input. In that case, your input voltage will be simply equal to only beta times of Re plus 1 plus beta times of Re. This will be your overall input voltage. Remember this. Okay. So this will be your new input voltage. If they are measuring it from the base terminal directly, they are not focusing on overall voltage gain. Observe the option. You can easily figure it out. So while writing the final answer, suppose if the base resistance is not there, sir, in the question, then it's okay. They ignored that. They calculated only from the base terminal. So your answer is going to be beta times of Re plus 1 plus beta times of this Re is different. This Re is different. This is the equivalent model of transistor internal circuit. So that Re will be calculated with the help of, how will you calculate, sir? This Re will be given in the question. This Re will be calculated with the help of ideality factor eta times of thermal voltage divided by collector current or emitter current approximately. Okay, people will be using collector or emitter, both will give you same answer, because we know collector current is almost approximately equal to emitter current, because the value of beta is usually very large. Because of this reason, the value of the base current will always be very small. See, we are demanding very low value of small base value of the current, because base current is it's a driver. A very small amount, minute amount of current is sufficient to drive the transistor. So usually the base current will be very small always, because of, so in order to make this small, we are focusing on this current gain to very large value. As long as high as possible, we are trying to maintain the value of beta current gain as high as possible, such that the value of beta current will be minimized here, and we are also controlling it with the help of base resistance. Anyway, come to the conclusion. Because of this low value, sometimes people will be using collector current here, emitter current here. Look at the option. They will not give both. Definitely they will not give collector current and emitter current both, because they know approximately the both are equal. Okay, fine, sir. This is how we are calculating value of Re. So both are different. Don't get confusion with the small Re and the capital Re. Now your final target is calculating the output resistor, output impedance, I can say. Output impedance is the one. It is the ratio between output voltage and output current. Output voltage minus beta times of Ib into collector resistance RC. This is the output voltage divided by the output current is going to be simply beta times of Ib, but minus beta times of Ib. We saw collector current and output current are in opposite direction, so they will get cancelled fully. So this is going to be just collector resistor only. Finish, sir. So I have given explanation for how to calculate these parameters. So it is very important to remember. Sir, my doubt is, Pratap, in AC analysis, if beta is given very large, then shall we put base current? No, you should not do that. Remember, you cannot make the value of base current equal to 0. That is what I am saying. In AC analysis, don't make the value of base current equal to 0 when the value of beta is very large. In the question, they will not mention whether you will have to perform AC analysis or DC analysis. All they will do is, they will be giving, simply assume the value of beta is very large. So you will have to consider that only while performing, if you are performing DC analysis, then take that point. It is a valid point. You can consider the value of base current equal to 0. After that, suppose in the same question, it is given beta is very large, but you are going to perform AC analysis. Then in that case, don't keep the value of base current equal to 0. If you do that, you may not be able to perform any analysis here. See, if I am putting base current equal to 0 everywhere, what will happen? Input impedance itself, see, this will become 0 by 0. And our voltage gain it will become 0, input voltage will become 0, output voltage will become 0. So it is not possible for you to perform any of the action. Suppose if you are taking the value of base current equal to 0, hope you will understand, you will not do it. Okay. So they will not mention whether you are going to perform AC or DC analysis. You will have to decide based on the question, what type of question they are asking. Whether they are asking voltage gain or current gain, input impedance or output impedance, or Q point, stability point, or type of in which region your transistor will be operating. Based on the question, you must decide whether we will have to perform DC analysis for this question or AC analysis. Okay, that's it. So let's continue. So this is how we are calculating. See, my suggestion is, even if you are reading the books at all, suppose most of you are doing self preparation. So I told you these classes are intentionally I am taking only for the people, mainly for the people who are doing self preparation. So what you have to do is, of course, you will be reading a lot of notes and watching a lot of lectures. That is, everything will be fine. But all you have to do is, everywhere you will have to learn the general approach. See, the one I thought till now, what we saw, how to calculate the voltage gain, or current gain, input impedance, output impedance. What I did I told you this is the standard, you have to memorize this method? No. The thing is, this is common procedure. You will have to apply. So see, for each and every circuit, if you started memorizing, that will be a difficult task. But for small formulas, you can remember. When we are going for lengthy formula, if you forget something, it will definitely at the same time you might have not remember the general procedure. That will affect you. That will kill your mark. So what you have to do is just what is the general approach. Don't focus on what type of circuit they are giving. Only thing is, if a transistor will be given, I know how to redraw it. What will you do? It doesn't matter whether it is RE model or IR pi model or hybrid model. It doesn't matter what method that you are following. All you have to do is how to replace this transistor. A simple step is, from the base terminal, I will have to connect a resistor. From the connected terminal, I will have to connect one current source. That's it. All you have to do is just, if you are writing RE model, then this will become RE, beta times of RE. In R pi model, this will be replaced by R pi. If you are performing a hybrid model, then it will be replaced by H high. If you are performing here, this is RE model. For R pi model, this is going to be GM into V pi. V pi is the one that you are measuring across here. Same thing. Just to think, the terms names will change. If you are performing, so in case of a hybrid model, this will become HF into base current IB. That's it. So the thing is, all these people are equal to each other, sir. No need to memorize all this. Sorry, no need to perform all the methods differently. Remember only one method. Clearly approach with that. Draw the equivalent circuit. After that, go to the base terminal. Okay. With the base terminal, if they are connecting some resistor, just to connect it here. Sometimes voltage divider circuit will be given. There will be some resistor that will be connected to the collector terminal. While performing AC analysis, this all are going to be connected to the ground, na sir. It means between this resistor will be directly flipped and connected to the ground. In that case, there will be a resistor. You will have to connect that resistor with the ground like this. Then you can continue. Then you can attach the base resistor. Are you getting me what I am saying? This resistor will be lies between this point to ground. A parallel resistor will appear. Whatever the things that they are giving, you can put it here. After that, if a base resistor will be given, yes, connect a base resistor. Then if a supply voltage will be given, yes, connect a supply voltage. Then go to collector terminal. Okay, observe whether the collector is directly connected to the ground, then directly connected to the ground. No sir, there is some resistor. If the collector resistor will be given, they have given certain resistor. See, across the collector terminal, if they have given any resistor, if they are giving RC like this and they are measuring the output voltage, simply connect this with the ground. Ground means between this point to ground. So this can be redrawn like this. Across the collector terminal, your resistor will become. It will be appeared between this point to ground. So directly you can keep your voltage across this point. Getting me, sir? So that is how you have to do. Sometimes here itself they will give some resistor, output resistance. Attach it parallelly. Already one more resistor is there. Now from the collector terminal, one more resistor is coming between ground and the same point. So now these two people are in parallel. So you can write RC and R0 both are in parallel. So it doesn't matter from where you are performing this analysis. Then go to emitter terminal. If the emitter is directly connected to the ground, then connect it. No sir, it is having some resistor, then attach the resistor. Sometimes they will measure the impedance from here also. It doesn't matter from where they are measuring the resistor. All you have to do is draw the equivalent circuit. Then from the point, from where they are measuring, from that point, try to calculate it. With the same approach, just to calculate bring the relation for output voltage, output current, input voltage and input current. So in your free time, spend some time to analyze how to calculate this output voltage, output current, everything. Okay. Sir, go to the analog playlist. Here I may not be able to derive everything. What you have to do now? I have uploaded all 11 subject fully with the in detailed explanation. I took the class and I made a playlist and it is uploaded on YouTube only. It is there in YouTube. Go to playlist, search for all subject, analog electronics, digital, everything. In analog electronics, watch all the whatever the things that you want, whatever the basics that you are looking for, you can watch over there. Otherwise, if you are not finding sufficient things, search for any YouTube. Go there. If you are not finding the content here, go there and try to figure out the answer and check how to calculate the voltage gain and all. Maybe this BJT not uploaded yet, but you can check the problem solving session. If you are observing analog electronics problem solving session, there you can find I taught how to calculate all these parameters. I have been solved so many questions. Just by observing the questions itself, you can easily learn how to perform all these things. Just cross check once. Fine. So this is all about AC analysis. In AC analysis, only these type of questions will be directly asked, especially from mid frequency analysis. Hope you all understand whatever the things that we have that we did so far. That's it. So with this, I am completing bipolar junction transistor concept. Apart from that, I may left some formulas. They are very short as easy formulas. Very easy formula. You can easily memorize those things from your hand. Okay, I'm skipping only a very few things. Like see, if you observe, there are some questions from current mirror circuits. There are some small circuits. If a current mirror circuit will be given, I will cover these things again. Don't worry. I'm going to start MOSFET. At the end of the MOSFET, I will bring this concept again. What is current mirror circuit? So what they will give, a simple transistor they will give like this. A matched transistor will be given. Sorry. So they will give a matched transistor and you will be requested to calculate the output current. They will give the reference current at this point. So this point they will connect it to the ground or some supply voltage, whatever. They will tell that these two are matched transistor and beta will be given. Beta is very large. Sometimes they will say beta is very large. Sometimes they will say beta 1 and beta 2 both are equal. Beta 1 and beta 2 both are equal for both the transistors. Both the transistors are identical to each other. So in current mirror circuit, both the transistors are always identical only, and this beta value will become equal only. What changes they will do is, the only difference will come, base to emitter voltage may be differ. Only focus on this. If it is given matched transistor, then there is no problem. If it is given general circuit, then you should not say these two people are equal. So you will have to consider base to emitter voltages are different. After that, since it is given beta values are same, then the base currents are going to be same. Same base current will go here. Same base current will go here. Here also it will become 2 times of IB, and here it will become collector current IC for this first transistor. Then I can say reference current equal to collector current plus 2 times of base current if you are applying KCL. At the same time, for the second transistor, I can say output current is nothing but collector current, because this is collector terminal. This will be equal to beta times of base current. So what I can say is, in place of this collector current IC, directly what you can put, both the transistors are matched transistors. Sir. What you can do is, you can directly write down. See, first I can replace it by beta times of IB. So this will become 2 times of beta into IB, because IC equal to beta times of IB. That is what I did here. From here we can say this will become 2 plus beta, that is fine. But this base current, this will be replaced by output current I naught by B. Output current I naught by B. So this is equal to reference current I reference. Now from here what you want? Output current I naught, that is going to be beta by 2 plus beta into I reference. So they will frame this type of questions. All you have to do is how to bring the relations between them. You should learn this type of theories will be available for current mirror circuit. So just to recollect once, don't focus on the things formulas at all. Just learn how to derive this, because in the exam they will give some general circuit. Sometimes they will give standard. In that case, if you remember the formula, you can derive. Even if you don't remember the formula, within fraction of 10 to 15 seconds, it will take maximum to bring the formula again. If you understand the circuit in a very well manner. Okay. Anyway, I will recollect this current mirror circuit once again at the end of the MOSFET, because in MOSFET also we will have to design the current mirror circuit, and you must know the difference between two current mirror circuits. Like in bipolar junction transistor, how our current mirror circuits will be seen, right? And in MOSFET, how to draw the current mirror circuit, what will be the basic difference? Because in both area questions will be framed. When you people are appearing for the exam, if you don't know the exact difference, you people are automatically confused. Fine, sir. So the next topic is we are going to start MOSFET. Okay. So this is what we are going to do in the next class. I'm just giving introduction. Tell me what is the definition for MOSFET first of all. This itself, most of the time questions will be framed. Any one of you? Do you know the expansion of MOSFET first? How many of you know the answer for MOSFET expansion? If you don't know, first learn it. Tell me, sir, what is the expansion for MOSFET? So you will have to learn this one, because sometimes what will happen, directly questions will be framed from this. I will say this is field effect transistor. Most of you might know. This is what metal. This is what oxide. Then what S stands for? What is S stands for, sir? Semiconductors. So by combining this, you can make what? Metal oxide semiconductor field effect transistor. So now let's continue with this. We are going to design once again. We are going to design. Yeah, you are correct. So just in MOSFET, what we are going to do? What is the basic difference between bipolar junction transistor and metal oxide semiconductor field effect transistor? We must know this difference. The first thing here, before starting this, in bipolar junction transistor, if you observe the internal configuration, if you focus, we are controlling this device with the help of a current is called base current. If the base current will be 0 ampere, then our MOSFET will enter. See, while performing the analysis, most of you are getting one doubt. The thing is, sir, in the question, if it is given beta is very large, we are assuming that the value of base current equal to 0. When it is given beta is very large, we are assuming that base current equal to 0. You are assuming, sir, it is not equal to 0. You are assuming because in calculation, the value of base current in microampere or it is a nanoampere. Most of the time it will be in microampere. Micro means after fraction you will be getting 50. Because of this reason, during the calculation we are taking approximately collector current equal to emitter current. We are saying approximately. We are assuming. We are using these words now. So base current is not equal to 0. You are making, because of very large value of beta on the paper. If I am calculating, suppose if I am adding the value of 2 which is 0.00001, this is approximately, I can say 2 only. This will not change our resultant answer. Because of this reason, this value is ignored. It doesn't mean that this is exactly equal to 0. Approximately we are making it 0. Understand? What if people are thinking, sir, if I will make base current equal to 0, then the transistor will off, no? It will be in cutoff region, no? Yes, you are correct. But that is exactly not equal to 0. You are assuming that value is 0. Okay? So you must keep these things in your mind. While solving the problem, don't get the doubt. We are approximating it equal to 0, but it is actually not equal to 0. On the paper, the resultant answer will not change if I am ignoring the effect of base current. Because of that, we are ignoring. It doesn't mean that the value of base current equal to 0. Understand? Let's continue. So next thing, If the base current is exactly equal to 0, then the transistor will enter into cutoff region. Exactly. There is no approximation. It is exactly equal to 0. Otherwise, based on the base current only, we can identify whether the transistor will switch on or not. So it is completely a current controlled device. With the help of this current only, we are controlling the BJT, bipolar junction transistor. When we are coming to MOSFET, when the moment we are talking about MOSFET, this MOSFET is having 3 terminals, and of course we will be representing the MOSFET in so many configurations. With the help of body, without body, see, the MOSFET will be represented in many different ways. So I will be going with only one way. I am not focusing on all the things. And see why we are creating a gap here. The gap is, since it is called metal oxide semiconductor field effect transistor, metal oxide, we are putting some oxide here. Okay, because of that, it will going to act as an insulator. What insulator will do? In insulator, current will be 0 ampere. So inside the MOSFET, from this terminal is called gate terminal. This is called gate, drain, source. Like in BJT, we have collector, base, emitter. In the same way, here also we have 3 terminal, but this is called drain, gate, source. Here the current should not enter through the gate terminal. In order to make the value of gate current equal to 0 ampere, we are insulating the gate terminal from drain to source terminal. So there will be never ever you can observe the current flow between gate to drain or gate to source. The value of the gate current will be fixed as 0 ampere by coating proper insulating material with the help of a proper insulating material. Understand, sir? So the gate current will be approaching to 0 ampere. Then what we are doing, sir, in gate terminal, in BJT, with the help of current, we are switching on the device or we are controlling the device. That's why we are calling it as current controlled device. This is called current controlled device. One more question. If it is not being controlled in terms of current in MOSFET, if the current will be 0, then how we are controlling it? With the help of the voltage, either by inserting positive or negative voltage. It depends on the type of the circuit. We are controlling the device. Because of that, this is called voltage controlled device. We are not controlling it with the help of current. We are controlling it with the help of voltage. So that's why we are calling it as voltage controlled device. That is the first primary difference. So what we observed, in BJT, base current is not equal to 0 when it is in operation, steady state. Whereas here under steady state, the value of gate voltage will not be equal to 0. Okay. After that, so next primary thing, I will tell you the difference. Here in BJT, in order to know the region of operation, anyway, the first step, cross check whether the base current is greater than or equal to 0. Because if the base current is 0, then the transistor will be in cutoff region. You no need to cross check. But I told you, when it is greater than 0, then you will have to cross check whether the value of collector to emitter voltage is greater than 0.2 or the value of collector to emitter voltage is less than 0.2. Sir, one more thing, you can keep in general base current less than or equal to 0. Sometimes what will happen now? For NPN transistor, you will be getting negative current. That is not allowed. Okay. Current is trying to travel in the opposite direction. So your transistor will be entered into cutoff region. Only for greater than 0. The base current must be greater than 0. Then only these conditions should be satisfied. Then only your transistor will enter into linear or saturation region. Then in the yesterday class, I told you the procedure, no? How to identify the region of operation. Based on that, you can perform further. The actions will be proceed. Then I have given the collector relations, everything like IC equal to beta times of IB. All these relations are valid only in linear region. Your saturation region, you should not approach this. You should not use this formula. This is also one more question. So what they will ask is, what is the relation between collector current and base current in saturation region? Your answer must be, they are independent. They are independent. Your answer is, the collector current and base current are independent. There is no any relation, sir. Why it is independent? Because this formula is invalid in saturation region. In saturation region, some people will be what? Saturated. You should not drive the circuit beyond that point. So once your circuit will be saturated, then you should not use this relation. Then your answer must be collector and base currents are independent of each other. You should not use this relation. Remember this. In base region, you can, sorry, in active region, you can use all these relations. Now coming to MOSFET, in MOSFET, as I told, the value of gate current will be 0. So only one current will be there, that is called drain current. The current that is draining, that is going from drain to source. See, MOSFET is a bidirectional device. So current can go from drain to source or source to drain, because we can, in both way, it is possible for us to make the current flow. In NPN transistor, if you are taking a specific transistor, it is not possible. Suppose if I am having an NPN transistor, it is not possible for you to reverse the direction. Only one direction of current will be allowed here. But here, a same device can be operated. In a single device, you can pass the current. So drain to source or source to ground, if the symbol is not given, if this direction is not given, remember that. So based on this direction only, you will have to identify where is the source terminal. Okay, let me continue. The next thing. Anyway, what is the general one? The current will always be going from, for you in the exam, they will frame the question in which direction will be clearly identified. There are so many, there are certain classifications are there to describe the MOSFET structure. I'm not focusing on all the things. I will draw the symbols later on. As of now, we will focus on only certain basics. Wait. So when we are observing the gate current, this will be 0. Only we will have drain current. Usually this will be going from drain to source. Now, we will have two different formula for this. Anyway, I am saying only drain current will appear. When the gate current will not be equal, sorry, will be 0. Only one current will be there, that is drain current. Apart from that, how to identify the region of operation for MOSFET? First thing, check the value of gate to source voltage is greater than given threshold voltage. A threshold voltage will be given for MOSFET. Threshold voltage is nothing but minimum turn on voltage or cut-in voltage required to switch on the MOSFET. If the value of gate to source voltage is greater than that minimum voltage, then your transistor will turn on. Otherwise, if the value of gate to source voltage is less than Vt, then your transistor is not switched on yet. It is in off mode. In order to switch on, first this condition should get satisfied. Next, cross check whether the value of drain to source voltage is greater than or equal to VGS minus VT, or the value of drain to source voltage is less than VGS minus VT. Cross check these two conditions. If this condition is satisfied, then your transistor will be operated in saturation region. If this condition will be satisfied, then your transistor will be operated in triode region. Okay, so triode or ohmic region. So only there are two regions. One is saturation region, another one is triode or ohmic region. So based on the condition, you can easily identify under which region your transistor. So first condition, you will have to cross check this one. Like in BJT, we are checking base current. Here we are checking VGS is greater than VT or not. There the base current is greater than 0 or not. That is what we are doing in BJT. Here we are checking this condition. Once it is done, then you will have to focus on these two. Now for these two different regions, we will have two different drain current. These things I will cover in the next class. Already I am crossing your time. So with this, let's wind up this session. Hope this session really helpful for every one of you. Do share it with all your friends, and if the lecture is really good, just click that like button, share it with, because it is completely free. I'm not making it for any cost. I'm doing it for the people who are doing self preparation. So you will have to support all the people, especially from Tamilnadu background. I know, we all know, I have started this institute only for those people who are belongs to Tamil Nadu, who are really suffering because of the education. You know, there will be no any standard study materials or things to learn to come for any exams. That's why I made all the lectures for free of cost. You can go to playlist, watch all the lectures. Meanwhile, watch all the problem solving videos, whatever the guidance that I had given in the lecture, in the class. Follow it properly. Try to solve as many questions as been possible from your end. Okay. Fine, sir. Let's wind up this session with this. We will meet in the next class. Thank you all.